Hello friends, today we will be taking great problems of various years related to shear strength of soil. So this is of 2017 and it is related to triaxial compression test. The name of the test is given to you, a CU test, consolidated undrained test, is conducted on a normally consolidated clay at confining pressure sigma 3 equal to 100 kilopascal and the deviatoric stress at failure sigma df is given as 80 kilopascal and the pore water pressure u equal to 50 kilopascal. Find the effective angle of friction. So this is a problem which was asked in 2017. So naturally, when you conduct a consolidated undrained test with measurement of pore water pressure, you can find out sigma 3 bar, because sigma 3 is already known to you. It will be the confining pressure minus pore water pressure. So this becomes 100 minus 50. So this becomes 50 kilopascal. Having got this and having this sigma df, that is deviatoric stress at failure, equal to 80 kilopascal, you can find out sigma 1 prime, which will be equal to sigma 3 prime plus sigma d at failure. So naturally, this is going to be 50 plus 80, that is 130 kilopascal. So I know by now sigma 1 prime, that is major principal stress, and sigma 3 prime, that is the minor principal stress. And the test is conducted on NC clay. So if you conduct on normally consolidated clay, the CU test, the value of cohesion parameter will be 0. And we can therefore, to find out effective angle of friction, we can use the relationship. Using relationship sigma 1 prime, you know it, equal to sigma 3 prime into tan square alpha. So this can be further written as sigma 3 prime into tan square alpha is 45 plus 5 prime by 2. Or sigma 1 prime is 130 kilopascal equal to sigma 3 prime is already known to us as 50 kilopascal into tan square 45 plus 5 prime by 2. So simplifying, we get the value of tan square 45 plus 5 prime by 2 will be 13 by 5. Therefore, the value of 5 prime can be computed. So you can take your calculator and calculate it. So I am going to calculate this value of by simplifying. This will be under root 13 divided by pi shift tan inverse. So what we get by simplifying here, that 45 plus 5 prime by 2 equal to 58.19 degree. Therefore, minus 45 multiplied by 2. Therefore, 5 prime equal to 26.38 degree. So on shear strength, this is one of the important problem that you can learn it. Now we will go to the next problem. So let's go to the next. The next problem of 2016, set 1. A drained triaxial compression test on a saturated clay yielded the effective shear strength parameters, effective shear strength parameters C prime equal to 15 kilopascal and phi prime equal to 22 degree. CU test on identical sample consolidated undrained test. So on an identical sample of clay, same clay, of this clay at a cell pressure of 200 kilopascal developed a pore water pressure of 150 kilopascal at failure. At failure. Find deviatoric stress, sigma D. So this is the problem. Or we can see the solution of this problem. So you can just see it is going to be a drain test, and you get the effective shear strength parameters. C prime is known to you and phi prime is also known to you. So when you have C prime and phi prime, and then you have got CU test, consolidated underdrain test, on an identical sample of this clay, the cell pressure you are going to have on identical sample, the cell pressure is 200 kPa, and the pore water pressure, increase in pore water pressure is this at failure. Therefore, sigma 3 prime becomes 200 minus 150, that is 50 kilopascal. Now, if you apply sigma 1 prime equal to sigma 3 prime tan square 45 plus 5 prime by 2 plus 2c prime into tan 45 plus 5 prime by 2, then you will be able to calculate by substituting the various values. Here you know already sigma 3 prime, which you have calculated. So sigma 3 prime is 50 45 55 56 So if you simplify this, you will be able to get the value of sigma 1 prime based on this equation. The relationship is already explained in detail. So, tan square 56 plus 154.37 kilopascal. But what is to be found out here is find at failure the value of sigma d. Sigma d will be sigma, you already know it, that sigma 1 equal to, or we can write like this, that sigma 1 prime equal to sigma 3 prime plus sigma df. Therefore, sigma df equal to sigma 1 prime minus sigma 3 prime. So, the values are known to us, and therefore, I will be able to calculate 154 minus 50 becomes 104.37 kilopascal. So, this is the answer of this problem. So, in the examination, you see that questions are not very tough. If you know it conceptually, you can apply the relationship and get it. It is straightforward questions. So, you can solve any problem on this very easily. Let's go to the next problem now. So, the next problem is like this. (2015) set 1, in an unconsolidated undrained test, in an UU, we can write it in short, unconsolidated undrained test, it is observed that an increase in cell pressure from 150 kilopascal to 250 kilopascal leads to a pore water pressure increase increase of 80 kilopascal. It is further observed that an increase of 50 kPa in sigma d, that is barometric stress, results in an increase of 50. It is further observed that an increase of 50 kilopascal in sigma d results an increase of 25 kilopascal. 25 kilopascal in pore pressure. Find the value of Skempton's pore pressure parameter B. You know that A and B I have already explained are the pore water pressure parameter. So we can see the solution now. So you are conducting a UU test, unconsolidated undrained test, and you observe that an increase in cell pressure from 150 to 250 kilopascal leads to a pore water pressure increase of 80 kilopascal. So what is the increase in the cell pressure? The increase in cell pressure delta sigma 3 is given to you as so in undrained test this is the increase, but the simultaneously the corresponding increase in pore water pressure delta U or U is going to be of 80 kilopascal. So delta U is also known to you. It is further observed that an increase of 50 kilopascal in sigma D results in an increase of 25 kilopascal in pore pressure. Find the value of Skempton's parameter B. So what is Skempton's parameter B? You know delta U1 I have already explained during theory is going to be B into delta sigma 3. So here delta sigma 3 is here the pore water pressure increase is 80 B, and the increase in pore water pressure is going to be 100. Therefore, the parameter B can be easily calculated as 80 by 100, that is just find out delta sigma 3 and corresponding increase in pore water pressure, and therefore from this relationship you can find out the Skempton's pore water pressure parameter B, which is 0.8. So 2015 problem was little different. It was you can also find out Skempton's parameter A also with this given data, but it is not being asked, but you know how to find it out. So now the next problem is 2012. So 2012 gate problem is effective angle of friction. Effective that is phi prime of a saturated phi soil. Phi soil is 38 degree. Find the ratio of shear stress to normal effective stress. To normal effective stress. Sigma n prime on the failure plane. So we can see the solution of this problem now. What is given here, you can see the effective phi prime is given to you, 38 degree, and it is for saturated phi soil. So for saturated phi soil, the value of tau is going to be, C will be 0. So it will be sigma n prime into, you know, Mohr-Coulomb's equation. So from Mohr-Coulomb's equation, you already know that this tau equal to C prime. That equation is already known to everyone. What is that? C prime will be 0 for sand. So we know that, or we can say tau upon sigma n prime equal to tan phi prime. So the phi prime value, so if I take my calculator, it is easy to calculate, 0.78. That is the answer. So this is quite simple. Now we can go to the next problem again. So various combinations I have chosen so that all types of problems you are exposed to, and theory you already know. I have already explained the theoretical part, so you can correlate. Now I am going to talk about a Venn shear test, a filled Venn shear test into a soft saturated silty clay yielded the torque T equal to 4.6 Newton meter at failure. So torque T is given to you. Find the peak undrained shear strength of this soil. So friends, take height of veins height is given as 100 mm. So h is given to you, and you are also given diameter d equal to 50 mm. The vein is completely the vein is completely inside the soil mass. So field wind shear test you are carrying out, and the torque T, so you can see the solution of this. Torque T is given to you. So this is 4.6 Newton meter. The shear strength is required in kilopascal in this problem. So convert it into kilonewton meter. So it will be 4.6 into 10 raised to minus 3 kilonewton meter. So torque T is known to you. Find the peak and range shear strength of this soil. So SU we know equal to capital T divided by pi d square into the complete veins are inside the soil. So H by 2 plus D by 6. So this is the expression. So if you substitute the value, you can find out the undrained shear strength. So I will substitute now. So T is already known to me, 4.6 into 10 raised to minus 3 divided by pi. Now, this must be converted into meter. So if I convert D, so it becomes 50 divided by 1000 meter. So it becomes 0.05 meter, and H will be 0.1 meter. So pi into d square into h by 2, that is 0.1 divided by 2 plus d by 6, so 0.05 divided by 6. This value will be in kilopascal. So by simplifying, let us take our calculator and simplify it. So I am going to have it is, the answer is 10.04 kilopascal. So the value of SU you have calculated, the answer. So you can calculate. Friends, we will go to the next problem now. So 2008 we will be taking now, so that you are exposed to all kinds of problem that can be asked in GATE examination. And numericals are very, very important in shear strength. So theory you can easily do it, But without knowing conceptually, you can't attempt the problem. Now, there is a problem on direct shear test. A direct shear test into a soft direct shear test was conducted on a phi soil. On a phi soil specimen. Under a normal stress of 200 kilopascal. The specimen failed at a shear stress of 100 kilopascal. Find the angle of internal friction. That is, you have to find out the value of phi. So it's quite simple. So you have box shear or direct shear test, and it was conducted on granular soil, phi soil, a specimen under a normal stress. So sigma n is given. Right? The specimen failed at a shear stress. So tau at failure shear stress at failure is 100 kilopascal. Therefore, you can apply tau equal to, for sandy soil, granular soil, sigma n into 10 phi. So tan phi equal to so that is 0.5. So calculate tan inverse 0.5. (26.56 degree). So this is the value of phi. This is the answer. Now, we'll take another problem of 2007. So now 2007, CD test, consolidated drain test. On a clay soil sample. Clay soil sample at a cell pressure of 100 kilopascal is conducted. What will be the pore water pressure at a sigma d, that is deviator stress, equal to 40 kilopascal. Now look here, it is drain test. So solution is quite simple. It is drain test. And in drain test, the pore water pressure dissipates. Isn't it? So dissipation of pore water pressure is allowed. So when you are applying the confining or cell pressure of 100 kilopascal in drain test, consolidated drain test, it will be released. So what will be the pore water pressure? Because the test is going to be CD test is a very slow test. And therefore, during shearing a stage, the pore water pressure is allowed to dissipate. And therefore, the pore water pressure equal to 0. So this is the answer of this problem. And in intelligent way, they have asked it. You should reply in an intelligent way based on simple theory. Then one problem that I would like to, that is 2018. Set 1. This problem is like this. Drain test on NC clay. Drained test on normally consolidated clay. Under effective confining pressure, effective confining pressure sigma 3 prime because it is effective. Under effective confining pressure, uh, of 200 kPa, drain test is performed. Sigma D at failure, the deviatoric stress at failure of this normally clay sample is given to you as 400 kilopascal for specimen 1. Now, another specimen identical now. Another identical specimen 2 has on a specimen 2 is subjected to undrained test. So on a specimen 1, you did drain test. Now on another specimen of the same clay, you are doing undrained test, yielding or having data sigma 3 equal to 200 kPa. Here the pore water pressure we have not deducted. Okay. Sigma 3 is given to you as 200 kPa, and sigma D at failure is given to you as 150 kPa. Find the pore water pressure developed. Pore water pressure developed. Easily you can do this problem. So good number of problems we have seen, so it should be easy. You have a consolidated, you have a drain test on a normally consolidated clay. So C will be 0, NC clay, and the effective confining, okay, it is effective confining pressure is given to you, and sigma df is also given to you. So sigma 1 prime equal to sigma 3 prime plus sigma df. So this is going to be 200, this one, plus 400, that is 600 kilopascal. Right? Now in drain test, what is the relationship between sigma 1 and sigma 3 prime? You know it. Sigma 1 prime equal to sigma 3 prime into tan square 45 plus 5 prime by 2. C component is anyway 0. So plus 2c will be 0. Therefore, 600 equal to 200 into tan square 45 plus 5 prime by 2. Solving this, you can find out 5 prime. So if you simplify it, let us simplify. 600 divided by 200, so it becomes 3. So tan 45 plus 5 prime by 2 equal to under root 3. So 45, you can calculate the value of 5. So let us calculate now. Under root 3 tan 3 equal to 60 degree minus 45 equal to 15 degree. So 5 prime is easily calculated as 15 multiplied by 2, that is 30 degree. So from specimen 1, you got this result. Now you have got another specimen. So another specimen, now in the solution part, we have got a specimen number 2. Now if you go to number 2, so identical sample and of the same soil is subjected to undrained test with sigma 3 and sigma. So sigma 1 equal to sigma 3, that is 200 plus 150. Sigma 1 will be 350 kilopascal. Find the pore water pressure. So now the sigma 1 prime will be 350 minus pore water pressure, and sigma 3 prime is already 200 minus pore water pressure. So the pore water pressure that is developed, and phi is already known from specimen 1. So relationship sigma 1 prime equal to sigma 3 prime tan square 45 plus 5 by 2, or 350 minus u divided by 200 minus u equal to tan square 60, isn't it? Therefore, it becomes simplifying 350 minus u or equal to 600 minus 3u. So 3u minus u, 2u equal to 250 kilopascal. Therefore, u equal to 125 kilopascal. So this is the simple way. This is the answer. So therefore, in this question, the pore water pressure developed is going to be 125 kilopascal. So with this, I have taken all the varieties of the numerical questions. Theory I have already explained, and if time permits, I will go deeper into this. But from gate point of view, this much is quite enough. You can have good practice and fare well. All the best. Thank you.